Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Statistics series and concerns box and whisker plots. This guide describes box and whisker plots and how to interpret them. It also discusses the level of data that are appropriate to use them with and situations in which to use them. Introduction. There are many different ways to present data in statistics. The most common are bar charts, pie charts and histograms. See study guides, bar charts, pie charts and histograms. One fairly recent addition to these diagrams is the box and whisker plot, sometimes called simply a box plot. They were devised by John Tukey in 1977 and offer a simple and effective way presenting and comparing datasets which do not follow an underlying distribution, non-parametric data. Often, box and whisker plots are used to present ordinal or ranked data. See study guide, levels of data. A typical box and whisker plot is shown below and is annotated to show you what each of the parts represent. You can clearly see why it is called a box and whisker plot. This is a box and whisker plot to show the distance of journey to work from citizens of two towns, A and B. The top line is the highest value in the data set. The top of the box is the upper quartile. The line in the box represents the median. The lower line of the box is the lower quartile. The lower line represents the lowest value in the data set. Features of box and whisker plots. There is no convention to say that box and whisker plots must be vertical, like the one on the previous page of this guide, and you will often see horizontal plots. However, for vertical plots, the top whisker is the highest value in the data set. The bottom whisker is the lowest value in the data set. The top of the box is the upper quartile of the data set. The bottom of the box is the lower quartile of the data set. The line in the box is the median of the data set. Note, the positions of the upper and lower whiskers can be defined in different ways, and these are discussed in the final section of this guide. These definitions are easily applied to horizontal box and whisker plots. The study guide, Measurements of Central Tendency, has more information about the median. You can find out more about upper and lower quartiles in the study guide, Measurements of Spread 1, Range and Interquartile Range. One of the great strengths of box and whisker plots is that they show a great deal of descriptive statistics of the dataset in a plain and clear way. For example, the difference between the top whisker and the bottom whisker is the range of the dataset. The height of the box is the interquartile range. The height of the box represents the middle 50% of the data. The whisker above the box represents top 25% of the data. The whisker below the box represents bottom 25% of the data. If the box is closer to the bottom whisker, then, in general, the data are positively skewed. If the box is closer to the top whisker, then, in general, the data are negatively skewed. You can find out more about the range and interquartile range in the study guide, Measurements of Spread 1, Range and Interquartile Range. Note, skewness is the statistical measure of how much a dataset bunches towards a higher or lower value. Its definition is beyond the remit of this guide, but you can talk to a learning enhancement tutor if you want to understand more about skewness. Using a box and whisker plot to compare datasets. Box and whisker plots are an excellent visual aid to help you compare datasets. For example, the plot on the first page of this guide can be used to make the following statements. The spread of journeys to work in town A is greater than that in town B. The range for town A is greater than that for town B. The median journey to work is slightly shorter from town B than from town A. The middle 50% of journeys encompass a narrower spread of distances in town A than town B. The interquartile range is smaller for town A. There is evidence that the data for town A are positively skewed. There is evidence that the data for town B are negatively skewed. The top 25% of journeys have a much larger spread for town A compared to town B. The bottom 25% of journeys for each town have roughly the same spread. Although these statements are not the result of statistical testing, having a good grasp of how datasets compare to each other in this way helps you understand any underlying trends in more depth. Adaptations of box and whisker plots. Even though the upper and lower quartiles are always used as the boundaries for the box, the position of the whiskers can vary. The plot on the first page of this guide uses the highest and lowest data values as the whiskers. There are other ways the whiskers can be positioned, such as 1 standard deviation above and below the mean, the lowest data point 1.5 times the interquartile range below the lower quartile, and the highest data point 1.5 times the interquartile range above the upper quartile. The xth and 100 minus xth percentiles, such as 2nd and 98th, or 5th and 95th. Other information is often included, such as an X to denote the position of the mean, where appropriate. Both outliers and data which is not included directly in the analysis can be accommodated by box and whisker plots. They are often shown outside of the whiskers and denoted by either a circle or an asterisk. If you are excluding data from your plot, you must ensure that you write why you are doing so in the text which accompanies the plot. You should also give a key which explains any extra symbols that you use. Further guidance and information. If you have any further questions about statistics or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a Learning Enhancement tutor in the Dean of Students office. Telephone 01603 592761. Email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills.